Hi there. Welcome back, Introstat students. So today we are going to do an exercise, which is to find the sample size, right? Sample size and the margin of error in a confidence interval for mean. So let's click on that. So before we attempt the questions, there's something that I wanted to talk about. So what is it I want to talk about? So margin of error, right? The margin of, well, let's write the confidence interval. So the t interval, how does the interval look like? The t interval look like this, right? X bar plus minus the t star times the times the s the standard deviation of the sample divided by root n. So this thing here, we call it the margin of error. And it is when you specify the margin of error, you want to find out what the sample size is. So let's say t star times s divided by root n. Okay, so this is where this is the margin of error, right? Margin of error. Now to find n, the formula is this. So n is greater than or equals to, right? To find n, you use this formula. You use the standard deviation of the sample times it by the t star divided by the margin of error, and then the whole thing square. Okay, remember it? Remember it? If you don't remember it, that's okay, because I'm not going to write it out here anyway. So let's read the question. Suppose that the ages of members in a large billiards league have a known standard deviation of sigma equals to 12 years. Hernando plans on taking a random sample of n members from this population to make a 95% confidence interval for the mean age in the league. He wants the margin of error to be no more than 5 years. Which of this is the smallest approximate sample size required to obtain the desired margin of error? So you remember what I said earlier, that the formula was this: n is greater equals to, what was it? S, the standard deviation of the sample, multiplied by the t star divided by margin of error square, right? So one problem is, how in the world can we get t star when we don't know n? Because what was the formula for t star? T star was inverse t, right? Wasn't this the area to the left, which we can use from here? So we can put 0.97, 0.975. And that works. But then how am I supposed to find t star when we don't know the sample size? Because the degrees of freedom is in it n minus 1, but we don't know n. So we cannot use t. Therefore, we have to estimate it using z, right? Z star. Okay? So in this case, what is my S? What is my standard deviation? 12. Okay? So since we know the standard deviation of the population, then we can use Z. Times, what is Z star then? Z star is, so this is 95%, right? The confidence level. So Z star, we can use inverse norm. Okay? And area to the left, which is 0.975. I hope you got this by now. And then 0 and 1, right? Mean is 0, standard deviation is 1. And whatever they get this value, you put it here, and then you divide by ME. Here, the margin of error, it says here, no more than 5. So the margin of error is 5. And whatever you get, and then you square. I want you to remember this, because what I'm about to do is I'm about to go to the calculator. I'm going to find out what, not this, I'm going to find out this, what Z star is. the inverse norm of 0.75, and then multiply by standard deviation, and then divide by margin of error.
Your weekly Friday heads up for the west parking lot. We'll have our driver's range in use this week. So if you can have your cars moved by 2:30, that will give them time to get started, and they won't have to practice running into cars. Thanks so much.
Okay, so second verse, go to inverse norm, and the error is 0.975. Standard deviation is mean is 0, standard deviation 1. So this is my z star, and I need to take that z star, multiply by the standard deviation. So multiply by the standard deviation, and then divided by 5. The margin of error is 5, divided by 5. And then I got to square, right? Why square? Because look at the formula, right? The formula is with the square. I found that the z star, I multiply by the standard deviation, and then divide by the margin of error, and now I need to square it. Okay, square, and it's 22.1268. Now we have to round up, right? So we round up to 23. Okay, so let's go to the next question. Dr. Ashby is studying the heart rate of adult male. Preliminary data suggests that the standard deviation of the heart rate for adult man is sigma equals to 7.5. He plans on taking a sample of N men, which we don't know, we're trying to find what sample size is, to construct a 99% confidence interval for the mean heart rate. He wants the margin of error to be no more than 3. So the formula is N is greater than, now the sigma, right? So it's sigma times the z star divided by margin of error, and the whole thing squared. So sigma we know is 7.5 times, we don't know the z star, which we can find out at 99% confidence interval, divided by ME. What is ME? ME is no more than 3. ME is 3. And then you got to square. So I'm going to go to the calculator. I'm going to try to find the z star. So in this case, z star is inverse norm, right? Area to the left, mean of 0, standard deviation of 1. Area to the left, so it's 99% is 0.995. Okay, so after I get this value on the calculator, I'm multiplying it by 7.5, divided by 3, and then I will square it. So second verse, go to inverse norm, 0.995, and the z star is 2.5758, blah blah blah, times it by the standard deviation of 7.5, then divided by the margin of error, which is 3, and then I need to square it. So it's 41.46. They'll round up to the nearest digit whole number, it'll be 42. So I hope this helps. Let me know if you have any question. Thank you very much. Bye bye.